we're looking at the law of cosines now for our next problem here. The law of cosines is not a proportionate relationship. It's a solving relationship between the lengths of the triangles. It says that if you have, say here, a squared, this length squared is equal to b squared plus c squared. Then we subtract 2 times b times c times the cosine of a. It's a lot. And these other two forms are the same thing, but instead of a squared is equal to, it's b squared is equal to, or c squared is equal to. Our first problem here is 6.5.28, and what we need to do is solve for this triangle ABC. We're given that angle B, measures 79 degrees. We're given that side A is 8.55. We're given that side C is 10.47. We need to find the measure of angle A, measure of angle C, and the length of side B. So let's set up this relationship right here. We're going to use the b squared is equal to variant of the law of cosines. And it's b squared is equal to a squared plus c squared minus 2ac times the cosine of angle B. We'll fill in the appropriate values. Law of cosines is long. I don't have enough space for it. Alright, and then we'll simplify all this stuff. If we do the calculations, we can find that this sum right here is 182, and we'll stick to 2 decimal places, 0.72, and this product right here is 34.16. So again, this sum is giving us this, and all of this product is giving us that. Now we just need to take the difference and we'll be set. And that difference is, let's see here, 148.56. But remember, this is equal to b squared. And we want b, not b squared. So that means that b is equal to, let's see here, take the square root of that, 12.19. Awesome. So we can go fill in our triangle here with the new value that we found. Now, here's the deal. We've got the angle pair, or the angle side pair of B. We've got angle B, we've got side B. We know side C. We know side A. To find angle A, to find angle C, we could just use the law of sines at this point. And in case you can't tell, the law of sines is quite a bit simpler than the law of cosines. Unless you're a massive nerd like me and you program the law of cosines into your calculator, then it's not really a big deal. Anyways, for the sake of demonstration, I'm going to continue to use the law of cosines. But I would go ahead and recommend that you use the law of sines when you have this sort of a relationship, a pair, and you're looking for the other pairs. Otherwise, you have to use the law of cosines, but I'm going to use the law of cosines anyways here. So let's find angle A first. We're going to have to set up that version of the law of cosines. We're going to have a squared is equal to b squared plus c squared minus 2 times a times c times the cosine of angle A. And it's the cosine of angle A that we're going to be looking for. That's what we want to solve for. Now, we'll go ahead and remember 12.19 for B. we'll put in the values that we had. A was, let me check my notes here, 8.55, right? So we'll have 8.55 squared is equal to 12.19 squared plus, let's see here, this is 10.47 squared minus 2, 8.55 times 10.47 times cosine of A. And we're going to take these values, subtract them, and then we're going to take this stuff and divide by it. So what we're actually going to have is going to look a little bit like this. We're going to have a squared minus b squared minus c squared divided by minus 2, we're looking for a, so 2bc is equal to cosine of A. But we're getting ahead of ourselves. Let's go back to this and see what the values are. When we do all the arithmetic, we end up here. So what we'll do is we'll go ahead and we'll subtract these two values. We'll have 73.10 minus 148.60 minus 109.62. That gives me negative 185.12. Then, that is not looking good. You see, right here, this is wrong. Because if I take that ratio, we're going to have 179.04 negative. This is greater than 1. Cosine isn't. We made a mistake. And it turns out when I computed this guy, I was using the wrong value. So this is incorrect. I computed AC instead of BC. So we'll just erase that, and instead we'll go ahead and moving too fast for my machine. Put in the right value, which was minus 255.26. Okay, now we'll take that ratio, and that's equal to cosine of A, and that ratio happens to be, let's see here, entry, oops, that divided by 255.26, 0.72, that's the cosine of A. So A is equal to the inverse cosine of that, which is, oops, my apologies here. This is equal to 43.95 degrees. See, can't tell on my end, but I'm actually kind of rushing this, which is a bad idea, because when you rush these things, especially something like the law of cosines, you start to make mistakes. There's already the first mistake that I made over here, calculating that incorrectly. The other mistake I made is I put a negative this into my calculator. When I took the ratio, I didn't have that as negative, and that gave me the cosine is equal to 136.48 degrees, which is not right. And then even when I was calculating, I then took the cosine inverse of this guy, which is, whoa, mega not right. So long story short, do these guys carefully. There's a lot going on. They're very involved. You need to be pretty careful with them. Now we found angle A. The next thing we have to do is find angle C. Again, I'm going to use the law of cosines to find it, but you can feel free to use the law of sines. Let's set up our equation. We're going to have C squared is equal to a squared plus b squared minus 2ab times the cosine of angle C. So C was 10.47 squared. Actually, instead of doing that, let's go ahead and let's manipulate this guy symbolically. That is to say, let's take C squared and we'll subtract, go ahead and we'll subtract a squared from this side, subtract b squared from this side. So we'll have c squared minus a squared minus b squared, and that's going to be equal to, well, there's no a squared or b squared on my right hand side anymore, minus 2ab cosine of c. And again, it's this cosine that we're interested in because we're interested in angle C. So to get that guy by itself, we're going to have to divide by minus 2ab. So we'll go ahead and we'll divide by minus 2ab. When I do that on the right hand side, I'll be just left with the cosine of C. And it's going to be equal to all of this in the numerator. That's the cosine of C. Let's go ahead and let's fill this in with some values. And I'm going to scrunch this guy way over there because I'm sure this is going to take up quite a bit of space. C squared, that's 10.47 squared minus 8.55 squared minus 12.19 squared divided by negative 2 times 8.55 times 12.19. I'm just going to go ahead and calculate that out. And we get that the cosine of angle C is equal to the ratio of, let's see here, negative 112.08 and negative 208.45, which is equal to, let's see here, 0.538, which is less than 1, which is great. And since we're doing this trig stuff with triangles, it's between 0 and 1, which is what we really want. Anything negative would be bad. So then we'll just take the inverse cosine of that, or arc cosine, for anybody that's old school out there, old school trigonometry. And the cosine of this is, that's on, oops, we don't want the cosine, we want the inverse cosine. Inverse cosine of it is 57.47. Again, you got to be careful. Make sure that you put this into the inverse cosine or arc cosine, as opposed to just taking the cosine of it like I did initially. Get you to the wrong answer. So we end up with C is equal to 57.47 degrees. This triangle has been solved for. We found length B, we found angle C, we found side A. That's all the sides, that's all the angles. We know all 6 measurements. It's been solved for. Now, I want to take a look at one more problem. Section 6.5, number 39. Okay, we're given an isosceles triangle. AB is equal to BC. We need to show that, oops, a little bit of carryover from the layers there. We need to show that b squared is equal to 2 times a squared times the quantity 1 minus the cosine of b, where the lengths a and b are as marked. To do this, we're going to use the law of cosines. So we'll start off with the b squared is equal to formulation of it. And this is just the law of cosines. Next, we were given that a is equal to c. So we can do a little bit of substitution here and get that b squared is equal to a squared plus, not c squared, but a squared minus 2 times a again times the cosine of b. Oops, too far. Now, a squared plus a squared, that's 2a squared. Minus 2 times a, that's minus 2 times a squared. This is all still equal to b squared. So, we combine these guys, we get this. We combine these guys, we get this. Now take a look. Each term has a factor of 2a squared in it. We can just go ahead and factor that out, pull that factor out. This first term is 2a squared times 1. This second term is 2a squared times a negative, can't forget that negative, cosine of b. Wait a minute, this looks awfully familiar. Oh, it's because it's what we were trying to show. Look at that, we're done. And that's section 6.5. That's triangle trig. Unless I get any requests, that's the end of the videos. Class is pretty much done. Thanks a lot. You guys have been great. You've turned out some really good work this summer. Keep it up. Do real well on that final exam. Get yourself some A's or something. All right. See ya.